Hello everyone, welcome to lecture 2 of GATE PYQ series, and the subject we are going to study is digital electronics. In previous video we have solved some examples. In this video we will try to solve some other examples. So let us start first one. So here is the question here. So you can pause this video here and solve this question. If you are able to solve, then you can directly jump into next one. So here let us see what is the given. Here the circuit consists of a JK flip-flops, each with an active low asynchronous reset input. There's a counter corresponding to the circuit is. So here we are given asynchronous counter here. So we have to uh, find whether this is a binary up counter or binary down counter. If so, which be modulo 5 or modulo 6 one. So we will solve this one here. So let us say, let us take here we are giving clock to Q0. So my LSB will be Q0, Q1 and Q2. So these are my bits. Now for every clock my Q0 will toggle, and for every time my Q0 goes from 1 to 0, my JK my second JK will toggle, and similarly the Q2 also. So now we will say, let us take initial as 0 0 0. So here we can say Q0 will toggle at first clock. It will go into 1. So this will be 0 and 0. And after this one, it next second clock, Q0 will go to 0. And since it is going from 1 to 0, then this will be another state. And similarly again for third clock, here I will get 1 and this will remain as it is, and this will be as it is. And for fourth clock, this will become 0, and since 1 0, and this will become 0, and since it is become from 1 to 0, and this will become 1. So fifth clock we are having 1 0 1. So when you see here, what is my this one is Q2 into Q0. So if this is 0, then my will if both are 1, then this reset will be enabled. So here Q2 and Q0 must be 1. So here Q2 and Q0 are 1. So here we are getting how many states? This one 0 to 4, that is 5 states. So it is a modulo 5 binary, and this one is counting upwards. This is 0, this is 1, this is 2, this is 3. So this is counting upwards. So this is modulo 5 up counter. So we will not consider this fifth clock, because since it is an asynchronous syncer, this state will this fifth clock, this state will be available only for momentary time. So as soon as this is Q2 and Q0 will go to high, my output will and my all flip flops will get reset. So this will be only available for momentary state, momentarily. So let us check which one is the answer. So here modulo 5 up counter, A is our answer. Next we will go to next one. Here we are given a modern counter using a asynchronous binary up counter. Here we are given it is a synchronous binary up counter with synchronous clear input. So here the clear input is also synchronous. So what will be my n? So we need to find which one. So in order to, when we find the relation between this one, QB and QC here, this is my QB, QC. So QB into QC. So whenever QB and QC are 1, so my output, so my counter will be cleared. So we will take QA as MSB, QB, QC, QD. So initial state, let us consider 0 0 0. So when will be my Q1, QB and QC will be 0. So the first state will be 0 and 0. So this is the first time where you will get QB and QC as 1. So what is the equivalent here? 6 is the equivalent. So what we can write from 0 0 to 0 1 1 0. So total 7 states. We are having total 7 states. So this will be a modulo 7 up counter. So here my value will be 7. So that is the meaning of this question. So next one we will come to next question. Here we are having a multiplexer based logic circuit. Here we are given here we are going W, and here we are getting W bar, and let us say this output is Y, and here I will have Y, and here I am having Y bar. So let us write output for Y. Y will be my S1 bar W plus S1 W, sorry, W bar, and this is we can write this one as S1 XOR W. W. Now we will find for second multiplexer. So here say for second multiplexer what we are having, my F is equal to, so here we are getting Y bar, right? S2 bar Y plus S2 Y bar, and here it is S2 XOR Y, and my Y is S2 XOR S1 XOR W. So this is my answer here. So here we are getting where are we having this option? This fourth one. So this is my answer.